Hi guys, welcome to lesson 12-2, Frequency and Histograms. So our objective for today is that I can make and interpret frequency tables and histograms. What is frequency and a frequency table, you might ask? Well, frequency is the number of data values in an interval. So how many times or how many pieces of data end up in that section. Frequency table groups a set of data values into intervals and shows the frequency for each interval. The intervals do not overlap, they do not have gaps, and usually they are of equal size. Okay. A histogram is a graph that can display data from a frequency table. So again, it's not going to have sections that overlap. It's not going to have gaps. Well, it might have gaps. The intervals won't have gaps. Sometimes we just won't have any data to report. And there are, again, they are usually of equal size. Yep, fancy bar graph. And then the last one we're going to deal with is the cumulative frequency table, which shows the number of data values that lie in or below a given interval. Okay. So it is, there are that essential understanding. There are many ways to organize and visually display data. Sometimes it's helpful to organize them into numerical data intervals. So the first one we're going to look at is making a frequency table. And you can see that Mrs. Zirzo has already pre-drawn some tables for us, so you don't have to sit there and wait for us to write those. So there's a tip here to find the number of, find how many possible values there are in a data set and then divide it into equal segments. It's not always going to work, but it can give you a head start on dividing up intervals. So we have letter A, the number of home runs by the batters in a home run derby are listed below. What is a frequency table that represents this data using an interval of 4? So in this one, I told you what the interval is. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, so what Mrs. Zirzo is doing, she's going through and counting up how many fall within the interval of 1 through 4. And a good trick is what she's doing there. Cross them off when you count them. That way, you know that you've counted them, and you can account for what you might have missed. Okay. I'm not going to talk and distract her. So we had 3 between 1 and 4, 4 between 5 and 8, 4 also between 9 and 12, 2 between 13 and 16, and 1 from 17 to 20.
Make sure you label your columns correctly.
Yep. All right, now letter B says, what would the frequency table look like if we used an interval of 5 instead? So 1 through 5, 6 through 10, 11 to 15, 16 to 20. So we're using the same data, and we're going to represent it in a different way. Okay, so there are 4 in section 1 through 5. There's 5 in section 6 through 10. 4 in 11 to 15. And 1 in 16 to 20. So you can see these are 2 valid frequency tables. They have all of the criteria we said. They are, nothing overlaps. There is no gaps in it, and they are roughly equal in size. And so we can see that the frequencies change a little bit. Okay.
When building a frequency table, to have at least 4 intervals would be appropriate. Less than 4 intervals, you really don't have much of a table to categorize your data.
Mm-hmm. All right, so letter C, why don't you guys try that one on your own, given the intervals that we've already provided you, and then check your answer with us. All right, so the quiz scores earned by 20 students are listed below. What is a frequency table that represents the data? So in 1 through 4, there's 3. So we have 12 in the 5 to 8 range. 5 in the 9 to 12, and we have 17 to 20 for some reason. Okay. So you can see there we have nothing in that final column. All right. Now, where have we seen something like this before? Maybe when we do our distributions of the test and quiz scores. Yeah, that's probably where we've seen that. Although in that one we do have one interval that is greater than all of the others because that F interval represents from 59% all the way down to 0%. So it's not a perfect frequency table, but it gets the job done.
So problem 1 was on how to make a frequency table. Now we're going to make a histogram.
So there's multiple ways to approach doing a histogram. One of them would be to create a frequency table first and then make a histogram from it. Or we could just go into making a histogram with the frequency. So what you need to do is count up how much is going to be in each of our intervals. So you have our intervals located on the x-axis of this graph, and the frequency is on our y-axis. So Mrs. Zerzo is going to count them up. So there were 3, and you'll notice the bar is the width of the interval. It's the whole width. So then we're going to look in our second interval. And we have 5 data entries. Okay. So this is a bar graph that has the bars touching each other. They're next to each other.
Your histograms must touch each other, no gaps.
Yes. We have 3 in the next interval. And 17 to 20. We have nothing, so we're just going to have our bar at 0. And 21 to 24, we only have 1, so we have it there. Okay? All right, so finishing times in seconds for a race are shown below. What is a histogram that represents the data? All right, so we're going to do the same thing. We've got section 80 to 84. 1, 2, 3, 4 entries. Section 85 to 89. We only have 1 entry. 90 to 94. There's 1, 2 entries. 95 to 99 has 1, 2 entries, 3 entries. 3 entries.
Why did I miss this?
I don't know.
I just didn't cross it
I
out.
just didn't cross it off. Okay, so we have 3 entries there. 100 to 104, there's 1 entry. And 105 to 109, there's also 1 entry. Okay. So I want you guys to try letter C on your own. And we'll go over it. Okay, check in class. We'll go over it in class. All right. So problem 3 is interpreting histograms. So we're going to describe what we are seeing in terms of the shape of the histograms. So in the first window there, you see a graph where roughly the bars are the same height. So do they have to be exactly the same height? No, they just have to be close to the same height. So if 1 or 2 or maybe 1 data point higher or lower, that's okay. It's going to be uniform. The middle one there is if a vertical line can divide the histogram into two even parts that are mirror images or pretty close to it, then we call that symmetric. So if you have ever heard of the bell curve in terms of scores or intelligence or whatever, the bell curve is a symmetric histogram. Okay. The third one is if there is one peak and it's not in the center, we call that skewed because it's skewed to one side.
This one happens to be skewed to the right.
On the Chapter 10 test that we took, our histogram was skewed to the left.
The first one.
Yeah, the original. Skewed towards the F. All right. So we've got the number of dollars that Jay is spending on lunch in the last 2 weeks, and we want to make a histogram of this data, and then identify is it uniform, symmetric, or skewed. Okay, so between 1 and 4, he's got 2 days that he spent between $1 and $4. He spent between $5 and $9 1, 2, 3, 4, 5 times.
A little bit of Sesame Street here. Where's the count when I need them?
I was about to do that.
Oh, sorry.
Way to ruin the surprise.
Okay, do it now.
1, 2, 3, 4, 5 data points. Was it worth it?
It was.
All right, 15 to 19, we have 2 data points. All right, so there we go. So I would say that this one we would probably describe as being symmetric.
Symmetric.
You can draw a line down the center of that graph, and you would have rough mirror images, or in this case, exact mirror images on both sides. So letter B is the graph skewed, uniform, or symmetric. I read that completely out of order. And that's going to be skewed because you can see that peak is not in the center. It's pushed off to the left-hand side. So it's skewed to the left.
To the left, to the left. Everything you own in a box to the left. Okay. Sorry.
Letter C is the histogram, uniform, symmetric, or skewed. Well, looks like we can draw a line down the center of that, and it's mirrored, so if we can, that is going to be a symmetric graph. Okay. All right. Problem 4, making a cumulative frequency table. So this, remember, we said is the value of everything at that line and below. So the number of text messages sent on one day by different students are shown. What is the cumulative frequency table? Clearly, this was created many, many years ago.
When you actually had to pay for texts.
Right.
Back in the day when we actually had to pay to send texts.
Dime a piece, was it?
Yeah, something like that.
Something like that. All right, so the frequency is 11, so that means our cumulative frequency is 11. That's what we're starting with. There's nothing below that interval. Our second interval of 10 through 19. We have 3 entries, so now we do 11 plus 3, which is 14. There are 14 data points that are at or below 19 text messages. So we have 3 more for the 20 to 29 range. So that gives us a total of 17. Two more adds up to 19, and then 2 more gives us 21. Blackjack. All right. Letter B, what is the cumulative frequency table that represents the data below? So there are 1, 2, 3, 4, 5, 6, 7 data points between 0 and 5. So our cumulative frequency column is 7.
I think I missed one. You started counting at the same time I did.
Sorry.
1, 2, 3, 4, 5, 6, 7. Okay, so that one was okay.
Okay.
All right.
6 to 11.
2, 3, 5.
5 data points
Jeez.
there. 7 plus 5 is 12. 12 to 17. 1, 2, 3, 4. 12 plus 4 is 16. All right, I want you guys to try letter C on your own, and then we will go over it. So the ages of people at a family restaurant one evening are shown below. What is a cumulative frequency table that represents the data? So there were 4 people between 0 and 9. We had 2 people, 3 people. 3 people between 10 and 19. Only 2 people in their 20s. Six people in their 30s. Five people in their 40s. And 2 people in their 50s. So that brings us to a total of 22. Okay. All right. That's it for this lesson. Make sure you fill out your level of understanding. Write down any questions or confusions you may have come up with during the course of the lesson, and write your summary of what you learned and how you can make histograms and frequency tables. Have a great night.